obstacles and
Yeah, we're going.
in general? Okay. Here, do you want to also bring it closer to me so they can actually see the...
Yeah, so I'm focusing on obstacle right now.
Okay, all right, I'll start. So we're going to create, we've thought about this a little bit, we're going to create an obstacle class. And for the assignment for Arcanoids, we need to create bricks, power-ups, and then also levels. Right now we've really focused on how to implement bricks and levels, and we decided that really an obstacle class was the right way to go. An obstacle is going to extend image, and we're going to build some logic into obstacle called isImpact. And for every mover, we're going to have the mover on the update method for the mover. We're going to have a call the obstacle isImpact method. And essentially, that's going to determine whether or not there has been an impact. And impacts can be done with brick, which extends obstacle, or we can also have impacts with power-ups, which also obviously extend obstacles. So the mover will essentially be able to determine whether or not there has in fact been an impact. And upon impact, what's going to happen is we're going to call, we're going to have an abstract method called upon impact inside of obstacle, and we're going to let brick implement the upon impact abstract method. In brick's case, brick is going to have a hit count, a dimension, a file name, because it's obviously all associated with image, which is what obstacle extends, and brick's also going to have a power-up. The reasoning behind that is if you hit a brick, then what's going to happen is it's going to, if you hit a brick so many times such that hit count decreases to 0, then it's going to in fact turn into a power-up, or has a potential to turn into a power-up. So anyways, going back to this, every mover is going to check to see if it hits an obstacle. If it does hit an obstacle, the obstacle is going to call its upon impact method. In brick's case, the upon impact method is going to, basically bounce the ball off of the dimension, off of, the image, and it's going to subtract from hit count, and it's going to return the power up if in fact hit count is equal to 0. So that's kind of brick in a nutshell. Moving on to the power-up class that we talked about. Power-up again extends obstacle, and basically power-up, so it extends obstacle, which means that it's of type image. As a result, it's going to have a file name and some dimensions, and we're going to be calling the isImpact in obstacle, and essentially if there is an impact, then what we're going to do is we're going to call the upon impact method, which will take in a mover, and it's going to determine, it's going to actually call, we're going to get rid of this, it's going to call the obstacle impact method that belongs to the mover for this particular object, so this power-up. So what that means is we're going to basically add a new method to the mover class called obstacle impact, and we're going to make it abstract. So all movers are going to have to implement the obstacle impact method. And essentially, what obstacle impact is going to do is it's going to take in an obstacle, and it's going to interact with that obstacle somehow. Upon impact, it's going to do certain things. So we're thinking, just sketching it out in our minds, we're going to have a paddle class, and upon obstacle impact, we're going to get an obstacle. We're going to determine if the obstacle is of type power up, and depending on what type of power up it in fact is, we're going to do some code. We're going to do something to modify the paddle according to whatever type of power up it is. So that's kind of it.